So here's a sample task from illustrativemathematics.org, which, as I have mentioned in previous webinars, is the site that is being juried by the standard writer. So we can say with a bit of confidence that this is a task that might look like something that they might see on the new assessment. So here they're asking to find the area of each letter that has been made here with these little, grid pieces. And what you notice here that I think is interesting is that they're asked to try to work it out without counting each square individually. And if we think back to those standards that we just looked at, this has, basically all of them involved. Where I have to understand what the concept of area is, but I'm not interested in the distance around the shape. And if you notice, it tells me that this picture measures 1 centimeter on each side, so I've got to extend that to then know that each square is 1 square centimeter. And then also the idea that there are going to be counting some of these squares to get an idea of pieces and parts, but then I can actually even move beyond and go to some of the other concepts that I've been studying in geometry that deal with shape and talk about symmetry. And so I don't even have to find the whole shape. I can cut these shapes up, which goes into that, decomposition and recomposition standard 7B that we just talked about. And I can then deduce and figure out what the total area is without having to manually count every single square. And so this has a lot of depth involved if you really get into the discussion of how the students came to solve the problem. Now, if you have a 3rd grade class and you're trying to scaffold this task, you could do a divide and conquer where different groups would do different letters. You could do find the area of one and use that area to estimate the area of the next one. Does it look like there are more squares or fewer squares in this one? You could also then, not even worry about the answer per se, but focus on strategy. So, or focus on both at once. I would probably lean toward focusing on both at once. And so this becomes a task that can be very rich if we think about those standards for mathematical practice and having students critique their each other's reasoning. Okay. So let's then now look at 4th grade then. We're staying with this theme of geometric measurement. And you'll see that this is, kind of a ramping up of as we go from 3rd to 4th to 5th grade, but these standards in particular take a little bit of a different route. And so in 4th grade, I'm still going to be dealing with measurement in the context of geometry, but I have this introduction of the idea of angles. And so first I have to define the angle, which is there in standard 5, the whole idea that an angle is formed with 2 rays that share a common endpoint. Understand that it doesn't matter how long the rays are that make the angle, it's about the span that the angle encloses. And so they do mention specifically that, how we measure angles is with reference to circles, and as well as the idea of degrees. And so this idea of measuring a span is very different from the sense of we're not really measuring any characteristics of the shape to come up with it other than the actual angular measure. And let me explain to you what I mean by that. What happens many times in geometric measurement is there becomes a lot of confusion because kids measure along the side length of a rectangle and then do this magic math and they get the area. And so you're actually using a different attribute to come up with a measurement. So, and it gets even worse in 5th grade, which we'll talk about in a moment. But in angle measurement, what's interesting to note is that you actually have to measure that attribute. You don't measure the length of that rays and do some magic math and come up with the angle measure. Now, In future grade levels, we'll use ratios to do that, but that'll come after a whole lot more geometry. But what happens too often in the intermediate grades in particular is that we proceduralize the measurement. So in this case, if we don't go back to that attribute idea, then kids are going to have a real hard time with this because they've gotten lulled into thinking that measurement is all about something with side length, something to do with a linear measure. And that is not the case. And so it's really important that we distinguish that in fourth grade. And so, so we're going to define what angles are. We're going to talk about what characteristics, what attribute we're measuring. We're measuring that span between the two rays. And also then how to use a protractor. And so there's several, kind of pieces and parts that may get kids to be a little more, I don't know, not confused, but make this a little bit of a different geometric measurement experience than what they've had in the past. So let's keep that in mind. And so we've got this idea of defining what angles are, measuring in whole number degrees, and then if we look at standard 7 here, we then become worried about this idea of angle measures being additive. And it's similar to the measurement process that we've been going through with area and length. And so that's another kind of vertical and, vertical coherence piece where you'll see that in many of these geometric measurement instances, we first define what the measurement's going to be, and then we talk about whether or not it's additive, whether or not there's a process we can use to look at angle measures that might be difficult to work with, or if we want to combine two angle measures. And so, again, and this is a vertical coherence piece, we have to emphasize to the kids that the angle measures can't have any overlapping parts. They can have some coinciding parts, be right alongside of each other, but it's important that they not overlap. So that's a consistency there that they should be hearing throughout their geometric measurement experiences. And then you see that our next task then is to use those ideas about angle measurements to solve addition and subtraction problems. So let's look at an example here. And this example, if you listen to session 3 of this webinar series, you actually saw the same task. And this task is also tagged to geometry, as you see there. So what you'll find when you look at illustrativemathematics.org is that sometimes these tasks get tagged to more than one domain. And that's important to know when you give the task, because that implies that there's a couple of ways that kids could attack this, as well as the other content that they need to know to be able to do this task. And so in this case, if I don't know that rectangles have 90-degree angles, I'm going to have a difficult time doing this task. Although, if I have a protractor and I've done the fourth grade standards, it might help me reinforce that angles angles in a rectangle have 90 degrees of measure. So there's a couple different ways kids could attack this. And so what's important as a teacher is that you find out from the students, what they do. Now, what you also see here is an important mention of notation. So I have to know how to read angle CAD and what that means and how that makes an angle BAC. And so you may need to spend some time with kids if they need to have some kind of symbol notebook, if they've been keeping one for math class or any kind of, other kind of notation guide. They might have to reinforce here these kind of technical literacy. But what you want to get from kids then, so you may have some kids that take this from a purely analysis standpoint and say, okay, so I know that rectangles have 90 degrees. I also know that angles are additive, and that those two angles that I'm looking at in this shape make up the two angles I'm interested in. So if I just subtract 31 from 90, I've got my answer. You'll have others who may have to use a protractor, and then you may have others who take other approaches. So it's important that you use this task as a way to kind of hear what portion of your class is looking at this from different different perspectives.